previous class, what I already discussed in the unit number 2, you have learned an electron in an atom is characterized by a set of 4 quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. And also you learned the principal quantum number n defines the main energy level known as shell. We have also studied about the filling of the electrons into different subshells as per S, P, D, F in an atom. S orbital, maximum electrons it can occupy, that number is 2. For P orbitals, total number of electrons occupied the 3 orbitals Px, Py, Pz, this is the 6. And D subshell, it has the 5 orbitals. You already know from the previous class during the discussion of the unit 2. Total number of electrons, maximum number of electrons it can be occupied is 10. And for F subshell, it has 7 orbitals. And the distribution of electrons into orbitals of an atom is called as electronic configuration. And with this electronic configuration, we'll identify the relation with the elements in periodic table. That means an electron's location in the periodic table reflects the quantum number of the last orbital filled. Today's learning point is to observe a direct connection between the electronic configurations of the elements and the long form of the periodic table. Long form of the periodic table already I discussed. You can check the previous class to go in details about the long form of the periodic table. The period, we already know from the previous class, it indicates the value of n. N means principal quantum number for the outermost or valence shell. Successive period in the periodic table is associated with the filling of the next higher principal energy levels. That means when n is equal to 1, n is equal to 2, n is equal to 3, etc. It can be readily seen that the number of elements in each period is twice the number of atomic orbitals available in the energy level that is being filled. That means when the n is equal to 1, then that means it is the first period. So first period contains the elements is 1 multiplied by 2 is equal to 2 elements. And when you consider the period 2, when the principal quantum number is 2, in that case, the number of the atomic orbitals in when the principal number is 2, that time it is the 4. That means 2 s orbitals and 2 p orbitals. 2 p orbitals has 2 px, 2 py, 2 pz. So total number of orbitals in the shell having the n is equal to 2. In that case, it is the total number of atomic orbitals is 4. And in this case, the elements will be double of the atomic orbitals. That means 8 number of elements in the second period, and so on. We'll go in details about this. So first, once again, you relook the long periodic table. You see, this is the period 1, period 2, period 3, period 4, period 5, period 6, period 7, and lanthanides and actinides series. One by one, I'll describe now. In the first period, when n is equal to 1, then it starts with filling of the lowest level, that means 1s orbitals, and 1s orbitals, it will be filled up by one electrons, and this first period will contain 2 elements, that means hydrogen whose electron configuration is 1s1 and helium and its configuration is 1s2. So first period contains 2 elements. Now for the second period. Second period, it has the 2s orbitals, and 2s orbitals, it has the first, you can see the lithium. Lithium is the 2s1, that means full configuration is 1s2, 2s1 for lithium. And then it is the beryllium. In this figure, you can see it is the beryllium. Beryllium means total 4 electrons, and it's, in that case, the configuration is 1s2, 2s2. And in addition to 2s orbitals, there is the 3 numbers of p orbitals. That means 3 numbers of 2p orbitals, it will fill up one by one with electron for getting different elements. And then this is the L shell. That means the second shell. It is in old version we used to call the L shell, and L shell last element is neon. Its configuration is 2s2, 2p6. So you can see the this is the boron. Boron is the outer shell having electron configuration 2s2, 2p1. For carbon, electron configuration 2s2, 2p2. For nitrogen, its electronic configuration, nitrogen atomic number is 7, so electron in neutral nitrogen atom, it is the 7, so its outer shell configuration 2s2, 2p3. And for oxygen, whose atomic number is 8, then outer shell configuration is 2s2, 2p4. And fluorine atom, it has electronic configuration is 2s2, 2p5. And finally, what I told that for neon, it is the outer shell's configuration 2s2, 2p6. Now we'll go for the third period, where the principal quantum number n is equal to 3. So here also you can find the 8 elements: sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and last argon is the noble gas. So if you see its electronic configuration, for sodium it is the 3s1, for magnesium 3s2, outer shell electron configuration, and then aluminum 3s2, 3p1, and so on. And last for the argon, its outer shell configuration is 3s2, 3p6. So third period also have the 8 elements. Now period number 4. In period number 4, you can see that now d orbital is arrived, and d orbitals means D subshell, it has the 5 orbitals, what we already know from the previous class. That means in addition to 4 s orbitals, there are 4 p orbitals and 10 d orbitals. So it can be noted that before the p orbitals is filled, filling up the 3d orbitals becomes energetically favorable. And this already we know from the above principle, whatever I already discussed in the previous class. You can find it in the unit number 2. And then we came across the so-called 3D transition series. These all are 3D transition series. What is the transition series? We'll discuss later. Now, this much only you will know that 3D transition series of elements. This is from the group number 3. Here you can see up to group number 12. That means from scandium to zinc. And the 3d orbitals is filled at zinc. Zinc is the Z is equal to 30. That means atomic number is 30. Z is denoted for the atomic number. And with configuration is 3d10 4s2. Here you can see the 3d10 4s2. And here you can see the 18 elements. Why 18 elements? Because the thing is that here already d orbitals is there. So 5 numbered d orbitals is there. 3 numbers p orbitals is there. And 1 number s orbitals there. So 5 plus 3 plus 1. That means total 9 number of orbitals. So 9 number of orbitals means 18 electrons can be occupied maximum. So 18 elements are present in the 4th period. Potassium, calcium, selenium, titanium, vanadium, chromium, and so on. And in this group, the last element in this period, the last element is a krypton. And you can see the last electronic configuration 4s2, 4p6. And obviously 3d10 is there. I'm talking about the outer shell configuration is the 4s2, 4p6. Now, we discuss on the 5th period at the principal quadrant 5. And here also, this last row, that means last period, it also you can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. That means here also 1 orbitals for the s, 3 numbers of p orbitals, and 5 numbers of d orbitals. That means total 9 numbers of orbitals present in the elements belongs to this group number 5. So total 18 elements present here like the 4th period. Here you can see all the electronic configuration here. And in this period, 5th period, it ends with the xenon. Its configuration is 5s2, 5p6. And it starts with the rubidium 5s2. Now we'll go for sixth period. Sixth period is a little bit different because sixth period contains the f orbitals. So it has the f orbitals. That means f orbitals, it has the 7 orbitals. That means f subshell contains 7 f orbitals. In addition, 5 d orbitals, 3 number of p orbitals, and 1 number of s orbitals. It means 7 plus 5 means 12, plus 3 means 15, and plus 1 means 16. So 16 numbers of total orbitals belongs to this sixth period. That means it's double. That means 32 numbers of elements present in this sixth period. And you can see in this table, periodic table, it starts from cesium, whose atomic number is 55, and it ends with Rn, whose atomic number is 86. And in addition, you can see when the lanthanum with atomic number 57, then in this particular group, similar types of elements, 14 elements, it is called the FNR transition elements, and this group is called the lanthanoids groups. And so if you count these both row, then it will be the 32 elements. Now I'll go the seventh period. This is the seventh period. It starts with atomic number 87 and it ends with the elements having atomic number 118. And this seventh period is similar to the sixth period with successive filling of up to the 7s, 5f, 6d, and 7p orbitals, and includes most of the man-made radioactive elements. That means if you count the total number of orbitals for 7s, 5f, 6d, and 7p, so total 16 orbitals. That means elements will be double of the atomic orbitals present in this period. So 2 multiplied with 16, here also 32 elements present there. And this period will end at the element with atomic number 118, which would belongs to the noble gas family. Why it will? That means it is yet to discover. But prediction from the periodic table, we understood that this element should be invented and will occupy this place in the periodic table.